20 meters per second, having made 2 turns inside the barrel whose length is equal to L, that is 2 meter, assuming that shell moves inside the barrel with uniform acceleration. Find angular velocity of its axial rotation at the moment when shell escapes the barrel. We have got a barrel of cannon or any rifle. Any shell which is at rest here escapes this barrel, and when it escapes, it's moving as well as translating. Within the barrel, there is a shell which is at rest initially, and within the barrel here it have got constant acceleration and constant angular acceleration, and it escapes with velocity. This velocity v is given 320 meters per second, and they had asked what is the angular velocity when it escapes. This acceleration is constant and angular acceleration is also constant within the barrel, and it's at rest. And this length of the barrel, they say it's equal to L. They had given the value of L, and number of turns, N is 2 turns, and L is equal to, what is L is equal to? It's 2 meter. Angular displacement is 2 pi into N. Now, first of all, I can determine acceleration. Since velocity is given, I can apply this equation: v square equal to u square plus 2s, v square is equal to 0 square plus 2 into a into, for s I will write L. So acceleration is v square by 2l. This is the constant acceleration. I can determine time. V is equal to u plus at. For v I will write v, u 0, acceleration v square by 2l into time. So time is 2l by v. I can determine time like this. That during this time, it's moving with constant angular acceleration. Angular acceleration I can write a by r. A by r. I can also write the expression for r. L is equal to r into theta, or L is equal to 2 pi n into r, or r is equal to L upon 2 pi n. So this would be acceleration. For acceleration I will write v square by 2l, and for r I will write 2 pi n upon L. So this is angular acceleration, 2 pi n v square by L square, or pi n. Now I will say omega is equal to omega square plus 2 alpha into theta. I will apply this equation. Omega square is equal to omega naught square is 0, 2. For alpha I will write pi n v square by L square. For theta I will write 2 pi n. or I will write omega is equal to omega naught plus alpha into t. Time is also given to us. Omega is equal to omega naught plus alpha into t. मैं किसी भी इक्वेशन से अब लिख सकता हूँ 0 प्लस अल्फा की जगह पर मैं लिखूंगा पाई एन वी स्क्वायर बाय एल स्क्वायर एंड फॉर टाइम आई विल राइट 2l बाय v. एक v कैंसिल हो जाएगा, एक l कैंसिल हो जाएगा एंड ओमेगा कम्स आउट टू बी 2 पाई n v बाय l. It seems this is the answer. Same answer we'll get from this equation as well. बड़े ध्यान से देखिए, इसमें सिर्फ जो एप्लीकेशन था v स्क्वायर इक्वल टू यू स्क्वायर प्लस 2s v इक्वल टू यू प्लस ए टी, यह जो शेल है यह इस तरह से रोटेट होता जाएगा. इसका कांस्टेंट एंगुलर एक्सीलरेशन भी होएगा, कांस्टेंट एक्सीलरेशन भी होएगा विदाउट स्लिपिंग. थीटा इज इक्वल टू और डिस्टेंस ट्रेवल्ड एल इक्वल टू आर थीटा, यह हमेशा होल्ड करेगा. v इक्वल टू ओमेगा इंटू आर होल्ड करेगा. एक्सीलरेशन इक्वल टू अल्फा इंटू आर होल्ड करेगा. और इस तरह से कांस्टेंट एक्सीलरेशन हमने निकाल दिया. टाइम जितने समय यह बैरल के अंदर एक्सीलरेट करता है, जीरो रेस्ट से रहते हुए कुछ वेलोसिटी एक्वायर करता है, उस वेलोसिटी से फायर होता है. वह एक्सीलरेशन, टाइम और उस दौरान कितनी डिस्टेंस ट्रेवल करा और उससे हमने रेडियस ऑफ शेल भी डिटरमाइन करा. और फिर हमने यह इक्वेशन अप्लाई करी, ओमेगा स्क्वायर इक्वल टू ओमेगा नॉट स्क्वायर प्लस 2 अल्फा थीटा और ओमेगा इक्वल टू ओमेगा नॉट प्लस अल्फा टी, एंड वी गॉट द आंसर. Now, let me solve problem number 1.46 for you. Let's read the problem statement. The solid body rotates according to this function. Angular displacement is AT minus BT cube, where A is 6 radian per second and B is 2 radian per second cube. Find mean value of angular velocity, mean value of angular displacement, angular acceleration averaged over 0, t equal to 0 to t equal to t naught, where t naught is the time when it stops. The angular acceleration of the body when it stops. Now, there is a problem. We know that angular velocity is d phi by dt. We differentiate it a minus 3 bt. This is the angular velocity of the particle. Angular acceleration is d omega by dt. We differentiate this function and the 3 bt square minus 6 bt. This is angular velocity and angular acceleration of particle as a function of time. Now, it stops. It stops when angular velocity becomes 0. and that time is, let us say, t naught. So 0 is equal to a minus 3b t square, t naught square. So t naught is under root of a by 3b. It stops at this time. Now, there is a condition when it stops. Now, then asked average velocity, average angular velocity of the particle over the time from 0 till it stops. So, I will say average angular velocity, it is defined as integral of omega dt from 0 to t naught upon dt, integral of dt from 0 to t naught. It can be also defined as angular displacement at t naught time minus angular displacement at 0 time upon t naught minus 0. You can always solve it. Angular displacement पे हमें t naught substitute करना पड़ेगा like this. Mean of angular velocity is a into, for t I will write under root of a by 3b minus b into a upon 3b whole cube, whole upon a by 3b minus 0. This is the average of angular velocity, the mean angular velocity, average over time. In the similar manner, mean of angular acceleration is defined as beta dt over 0 to t time upon integral of dt over 0 to t naught time. Or we may define that angular velocity at t naught time minus angular velocity at 0 time upon t naught minus 0. I will substitute it here like this. A and A is constant, so 3b into t square for t square I will write a upon 3b upon under root of a by 3b to the power half, and beta at t naught time is minus 6b t naught or minus 6b under root of a by 3b, and you will get this as equal to 3 minus 2 under root of 3ab. This is beta at t naught time, and calculate average of angular velocity. I think this you will get it equal to the under root of this, under root term would get cancelled, and a minus this 3 by 2 b this would be a minus b into a by 3b. So I think this would be equal to 2a by 3 something, 2a by 3, or let me see the answer and write directly here, 1.46. Upon solving it, you should get 2a by 3, and I think I can see that also, and this is under root of 3ab. It simply involves the definition of angular velocity angular acceleration and the condition when it stops. Angular displacement is given by this function. Angular velocity is d by dt of angular displacement. Angular acceleration is d by dt of angular velocity. I differentiated this function in order to get angular velocity, and I differentiated this function in order to get angular acceleration. It stops when angular velocity is 0. So this would give me time t naught, and in this manner I got time t naught. Now angular acceleration at this time t naught is minus 6b t naught, and for t naught I substituted this time, and we'll get angular acceleration when it stops. Mean of angular velocity. This is the basic definition, and mean of angular velocity can also be written in this manner. Final angular velocity, final angular displacement minus initial angular displacement upon final time minus initial time. I may write mean angular velocity by any of these two definitions, and I applied this definition in order to get mean angular velocity. This is the answer. Angular acceleration, this in the similar manner I can define it like this, or I can define it like this, and I substituted the values and got the answer. Please note it.